start with the conference, to open the conference. I wish you all a very fruitful conference and good discussions. And let's start with the first session. That is membrane technology in water treatment. And therefore I give the floor to Luther Broens from Pentair, and he will guide you through these sessions with 4 speakers. Luther, the floor is yours.
Thank you very much, Peter. First of all, I have changed glasses. Welcome here in this room on water and innovation. You are in the Netherlands in a very innovative environment when it comes to water technology and innovation. And we are talking about membranes this morning. And we all know membranes obey the rules of process intensification. On a small footprint you can do a lot of separation technology. I am myself very fond of membranes. I'm one of the co-founders of the famous X-Flow company, recently acquired by Pentair from the old Norid. There was a time that the Netherlands had the highest membrane density per capita, but then we sold a huge plant, some 16,000 cubic meters per hour in Kuwait, and the Kuwaitis are still at the top of the bill. We have a very, I think, a very nice program on membranes. Mind you that we have a setting in this country that we do a lot of research on membrane technology. For instance, the top institute, WETSES, in the north of the Netherlands. So this was my short introduction. And now I would like to give the floor to the first speaker, that is h.Timmer. Harry works with Oasen, and I forgot to tell that also our water companies, the potable water companies and the wastewater companies, are very innovative and embrace membrane technology all over the place. Harry, your title is Freshwater from Saltwater using less energy, and I'm very curious to hear about it. Please come forward.
Okay, thank you, Luther. Welcome at this early hour. The presentation is, as I said, fresh water from salt water with lower energy consumption. And I think it's a very innovative technique, and I'll present it to you today. These are the topics that we'll discuss. We'll start with a concise introduction of the problem that we face as Oasen, and the need of a new technique for drinking water production. And then we'll introduce the solution, which we call the P02 project, the project partners, and the research topics that we will research, and some planning and future use. There are about 20 slides, so I think I'll manage to be in time. This is our supply area. We're the water supply company in the western part of Holland. What you see on the picture is that our well fields are located very close to the River Rhine. So what we do is we abstract river water after riverbank filtration, and this water is free from pathogens and the most micropollutants, and then we have a purification of our own. This picture, I think, illustrates very clearly the relation of our well fields with the River Rhine. This is a well in the green shaft. This is the River Rhine. So we're very close. This is a nice picture which illustrates, I think, the problem that we face. What you see is a view to the west of Holland. This is the North Sea, and these are the branches of the River Rhine. And what we see in the summer of 2003, but even this spring, that if the sea level is low and the discharge of the River Rhine is, no, the sea level is high and the discharge is low of the River Rhine, then the salt from the sea moves inwards to, well, until here, here, and here. And these dots are our well fields. So what we see is that in front of our well fields, in the river, sometimes the chloride concentration is as high as 1,000 milligrams per liter. That's not too long, so it's 1 week, 2 weeks, 3 weeks. But, well, it affects very small our water quality. This illustration gives again what happens. Once in a while, salt water intrudes here and infiltrates in the river, and it's pumped up as a mixture at our well fields. That would not be a problem. As Jan-Peter said, we're living in a changing world, and there's climate change going on. And what we see, which is calculated by the Royal Dutch Meteorological Institute, say if there are 4 specific climate scenarios, and if we calculate the effect of these scenarios on the weather and on the sea level, then we find that in the future sea level will rise, the discharge of the River Rhine will diminish in summer, and that will have effect on our well fields. Because if you calculate the effect that you will have more and more often salt intrusion from the River Rhine, and we calculate the effect of these 4 scenarios on our well fields. These well fields are here. These are the 4 scenarios, 1, 2, 3, 4. We see that in some of these scenarios, the concentration of salt in our well fields will be higher as the standards that are set by the Dutch government. So we have a problem. The removal of salt is not so very, well, there are solutions for it. For example, at a plant at Ridderkerk, we have this solution. What you see is a cross-section of the underground at Ridderkerk, where we have salt water deep down, fresh water on top, where we normally abstract the water. And what we do is, what we have is an upconing of salt water to our well fields. So we installed 1 or 2 wells which abstract this brackish water. We put it through a membrane, and then we have drinking water. And if you blend it, 80% conventional treated water with 20% membrane water, well, we'll have a good solution. But there are several ja, daar gaat hij. There are some benefits and challenges about well, RO, membrane filtration. One is, well, the benefits are like the removal of salt. We have this collateral profit, or we say the removal of hardness and nutrients and micropollutants. In the case of a deep well abstracting brackish water, we have also the fresh keeper concept, which I will show later on. There are some challenges, and these are the costs. The membrane filtration is more expensive than conventional treatment, and even more problematic is the brine. We have, as a water supply company, we have a lot of water to produce. So if we need, and then we produce about 20 or 30% brine or concentrate. If we have, that's an enormous amount of money, or an enormous amount of volume of concentrate, and we have to get, well, we have to dispose this concentrate. And because of the effect on the environment and the Water Framework Directive, there are all we need permits and license to get rid of this brine, and that's not easy because it's a large volume. Another problem is that we cannot afford, as a water supply company, to throw away 30% of our production, because we have to deliver 40 million cubic meters a year to the customers, and we have a license to abstract water about 50 million, so there's not 30% over. When we talked about this problem with our colleagues at the Technical University Delft, Dr. Bas Heijman said, well, I have this idea, and that's great, and you might like it. He said, what if you build into a well, inline, a membrane unit, at about 70 meters depth, and you use the hydrostatic pressure that's there from the water. At 70 meters, it's 7 bar. It's enough to have a 50% recovery, and you only abstract the permeate 50%, and the concentrate you can push it away with a little extra pressure in the deep aquifer where it's salt anyway, and then you have a double concentrated groundwater injected deep in the underground. That will save energy, and you don't have any problems with the brine anymore. Oh. We like this idea very much, so we adopted the idea. We said, okay, we'll try to make it, to transform this idea to a realistic project. So we had some partners, the Logistical and Water Treatment Company, the Technical University Delft, heijman, it's a drilling company, our water supply company, and Waternet. And we said, well, let's do this. And because it has some innovative concepts in it, we said, okay, we'll try to find some fundings. So we found fundings with agentschap.nl, which is the Dutch government, and the province of South Holland, who also pays a lot of some of the costs. And of course, the project partners pay the most. Well, the same amount of the same pluses. The costs and the concentrates are taken care of, so we only have pluses. And the concept is depicted here. You abstract the brackish water, the drinking water is coming up, and the concentrate is pushed away deep down. Now we have Waternet, who takes this idea any further, because Waternet is also responsible for the water quality in the polder areas in the Netherlands. And this is a typical cross-section of a polder area in the Netherlands, and what we see is that in the deeper polders there's an upward seepage of salt water, and this seepage of salt water affect the agricultural use of this polder and the ecological value of this polder. So that's a problem. And then they found if that can be calculated. If we abstract about 10-20% of the salt water, and we make, well, let's say drinking water, then we don't only have drinking water, but we also have only fresh water seeping upwards, and then we have a great quality change and a better agricultural use and a better ecological use of this polder area. This is why Waternet is very interested in this concept. What are we intend to do? The next months we'll work on the detailed design of this well, you will understand that it's possible to make this well, but we like to make it as maintenance friendly as possible, because we don't want to remove all the RO membranes every 2 months or so. Once a year, we like to do maintenance on this system. We're working hard on the permits. There are about 5 parties, like the municipality and the province and the Dutch ministry, where we have to have a permit for this system. I think we'll have the installation working in about the summer of next year, and then we'll start the pilots. And I hope in 2 or 3 years we'll have conclusions. It's important to mention that next to this practical side, we have 2 students, PhD students, working on the research. Well, and what are the research questions that we have? One is these are practical. Logisticon and heijman will solve these, I hope. And this is these are the research questions which are taken by the Technical University. Jeroen Postumus is working on will the concentrate precipitate into the membrane, or will it precipitate into the discharge filter deep down? Where will the brine go is where F.Smits of Waternet is doing the research on. And we are very interested in this regulation and the Water Framework Directive, because as a water supply company we like to do this on a large scale, but we like to do it within the framework of the laws. One of the first results of F.Smits and Waternet is this simulation. Not yet. Well, please. What you see is a cross-section of our location in Ridderkerk. This is freshwater, this is saltwater. You'll see a simulation of 50 years. The first 10 years without a Puro well, just with only our own wells. And then after 10 years you'll see the effect of the installation of a Puro well, which abstracts the brackish water and infiltrates it down somewhere here. Please. So you see that the saltwater upconing in a normal situation, and after that we use the Puro concept. We keep the wells above fresh, and the salt freshwater interface stays about at the same level. Okay. There are more of these fabulous animations of Professor Dr. Theo Osborne on YouTube. What will we do next? What will be the future use? If it is a success, I think it can be used in coastal areas and semi-arid regions, but also in our countries. It might be interesting for industries and agriculture. Well, this is the last slide. There's one more. Thank you for your attention. Okay.
Thank you, Harry. You did very well, dead on time, and we saw indeed again a very innovative or an example of a very innovative collaboration in the Netherlands. Water companies, technological companies together.